Okay, today we'll be looking at some theorems associated with cyclic quadrilateral. And before then, we need to know the meaning of cyclic quadrilateral, like the definition, and also use a diagram to represent that. Okay, from the definition, okay, is a quadrilateral inscribed in a circle is called a cyclic quadrilateral. So whenever you have any quadrilateral, you know a quadrilateral is a four-sided polygon inscribed in a circle, then we know that it is a cyclic quadrilateral. Remember, inscribed meaning all the vertices must be on the circumference of the circle. So see what I'm saying? If you have something like this, so as you can see, we have three different diagrams. So they are all cyclic quadrilateral because as you can see, all the vertices are on the circumference. So it's a cyclic quadrilateral. Also this, all the vertices are on the circumference. Also this, these are all cyclic quadrilateral. So let's now state some theorems under this. We have two theorems here. The first one is this, that opposite angles of a cyclic quadrilateral are supplementary. So supplementary means they add up to 1/8. So if you have this diagram, so as you can see, so from the diagram and the statement, you see that a degree plus c degree is equal to 180, and b degree plus d degrees is 180. So that's the supplementary, they sum to 1/8. So let's prove this. Okay, look at the diagram. We have to prove that. So I'm using only one pair. So if I join A to O and C to O, that's to get our radius. So yes. So from this we apply our inscribed angle theorem. So applying our inscribed angle theorem, we'll see that this angle is 2D. Yes. So you see that, maybe let me use. So you see that this angle, using our inscribed angle theorem, is 2D. While the angle here is 2B. So by inscribed angle theorem, so we see that angle A OC is 2D, and also that angle AOC, that's for minor and major arc angle, that's for this. Okay, this should be our major arc. So for this minor arc AOC, so one is major, one is minor. So for this is our major, while this is our minor arc. So minor arc is 2D. So let me use that's minor arc, while this is major arc. So why these two are they are equal to 2D and 2B respectively is because of inscribed angle theorem. So that's the angle at the center is 2 times the inscribed angle. Therefore, we form angle at a point here. So we see that 2b plus 2d is 360. Why? Angle at a point. At a point. So we can factor 2. We're left to b plus d equals 360. So dividing both sides by 2, we have b degree plus d degree equals 360 over 2 is 1/8. So we've proved that. So whenever you sum the angle here and here is always 1/8. Okay, look at this quick example. We're asked to find the value of d. Find the value of d without wasting time. This is opposite this. So d is 180 minus that. So which is 150. So d is 150. So option B. So it's very quick. So this is just the first theorem on that. Okay, let's just solve another question. We're asked to find the value of x. So the same thing. We are given 2 opposite angles of a cyclic quadrilateral. We see that x plus 80 plus 3x plus 10 is 180. That's by opposite angle of a cyclic what? That's supplementary. So we simplify. X plus x is 4x. 80 plus 10 is 90. 180 degree off. So 180 minus 90 is 94x. Therefore, our x is 90 over 4, which is 45 over 2, which is 22.5. So the answer is B. So that's for the first theorem. So let's look at the second theorem. So the second theorem says that the exterior angles of a cyclic quadrilateral are congruent to the opposite interior angles. Exterior angles of a cyclic quadrilateral. So let's look at the diagram. We have a cyclic quadrilateral with exterior angles. Okay, maybe let me use blue. Okay. Let me use red. Maybe let me use black. So we have an exterior angles here and the interior. I want to relate interior and exterior angle. So if we call the interior angle B, this one interior angle B1. So the exterior angle this, let's call it, that's theta 1. Let's call this theta 2. Why this is interior, theta 3. Let the exterior be theta 4. This is exterior, this is interior, this is exterior. So if we call this theta 5, so let's call this theta 6. So okay, this is theta 7. Let's call this theta 8. So I purposely numbered it theta 1, theta 2. So do you see from this they said that the theorem states that theta 1 is equal to theta 2 and theta 3 is equal to theta 4. Theta 5 is theta 6 equal to theta 6. Theta 7 is equal to theta 8. So whenever you have a cyclic quadrilateral, once you extend to form an exterior angle, it's equal to the opposite interior. So you see this exterior equal to an opposite interior, which is theta 5. This interior theta 7 equal to exterior here. So that's it. So let's now prove this. So from what I just stated, so if I'll just take one pair. So if I take theta 1 and theta 2, so we want to prove that theta 1 is equal to theta 2. As you can see, since here is theta 1, by the first theorem, here should be 180 minus theta 1. By our first theorem. Are you following? And we have a straight line. So angle on a straight line is always 180. So therefore theta 1 is equal to theta 2. So see what I'm saying is that I'm saying that angle ADC is 180 minus theta 1 because of opposite angle of a cyclic quadrilateral. They're always supplementary. So therefore, if you sum this and it's stereo, this is a straight line. This is a straight line. So if you sum 180 minus 180 minus theta 1 plus theta 2, it must give us 180 degrees by angle on a straight line. So from this, 180 is here, 180, so theta 1 goes over, so you see that this implies that theta 1 is equal to theta 2. So we prove that. Let's now solve an equation on that. We're asked to find x, the value of x minus y. So using what I just proved now, you see that this interior, this exterior, you see that y plus 10 is equal to x minus 5. Y, exterior angle of a cyclic quadrilateral is always equal to that, equal to the opposite interior angle. So remember, we asked x minus y, so we'll move degree off. Y goes over to that side to be minus y. Y minus 5 comes over to be 10 plus 5, which is 15. So our answer is 15, option B. Or let's solve another one, the last one. We're asked to find a minus b. So using that same theorem, a minus b, from here you see that a is equal to 47 degrees. Yes. Why? Exterior angle of a cyclic what? So also b is equal to 23 degrees by that same reason. Remember, we're asked to find a minus b, therefore a degrees minus b degrees 47 minus 23, which is option B. So that's it for cyclic quadrilateral. We have two theorems on that. The opposite angles are supplementary, and the interior angle equals the exterior, opposite interior angle equals the exterior angle. So that's it. Thank you.